So, you know, a lot of this morning has been about data processing and data entry, et cetera, but I don't know about you all, but what I live for is looking at the data, evaluating the data, and getting it to answer my business questions. So we wanted to show you a couple of different ways that we think are, that we've been using the data out of the EIM system, kind of to show you some possibilities, maybe some of these things you've already done yourself. But the EIM system is kind of opening up some new possibilities that we haven't had before, some capabilities that we haven't had before. So we just wanted to walk you through a couple of those examples. So I'm going to open up ArcMap system, and not necessarily everyone is familiar with how to use GIS software. I'd encourage you to explore it if you have an interest. If you're interested in getting access to the agency's GIS software license to become a user, you can, work with your own program management to get the permission to have a seat on the pool license that Ecology maintains, and take some training and start to use the power of some of these amazing new ArcGIS tools that we have available to us. As you're looking at these tools that I show you here, some of the discussions that we've been having in the last year or so is, rather than having people have to go out to a third-party piece of software that's a little complicated to learn how to use, maybe some of these capabilities ought to be embedded directly into the EIM map service, so keep that in mind if you see something that you really like. So we're gonna walk through sort of 3 different scales of using the information in the EIM system, because a lot of you, particularly in the cleanup program or the Haz Waste program, are working on an independent site, and you're really not all that interested in what's happening beyond the boundaries of your site. That's just the nature of your business. Let me recenter here. So let's just talk about a site-specific example. You all remember Dom Real? Dom had some information loaded for the General Metals site in the Tacoma Tide Flats area. So what I did was I just downloaded the data out of EIM that had been entered into EIM for the General Metals site, and then I brought it into a GIS environment. And I located those wells according to the X and the Y and the Z, the normalized coordinates that are in the EIM system. I just pulled those into a GIS system. So the wells are plotting using that standard X and Y and Z datums that we established back in EIM. Now I'm displaying that in a GIS environment with a photo background. And here what I've done is I've just taken the water quality results for shallow arsenic and plotted those values for December. And now I have all of the tools available to me in a GIS analysis world to look at this information. For instance, there's all kinds of tools for spatial analysis. You can do Krieging contouring or inverse distance weighting contouring. You can do 3-dimensional contouring. You can do all kinds of cool stuff there. And I can do that I can break it down by time and do a series, I can do a whole series of these maps. Oops. Let's see if I can get to this. Yeah. I developed a whole series of these maps here for each one of the years that the data is available. I dropped it into PowerPoint, and I made an animation of the concentrations over the years for arsenic in shallow groundwater at this facility. So this is kind of handy. Another thing that we can do, and there's some real neat stuff that's going on, there's a statistical program called R that a lot of people are starting to use, and Lori Morgan and a number of other people have been doing some really cool and clever things where you can automate, you can take the EIM data that's stored for a particular parameter, it doesn't matter whether it's a water quality or water level, and you can fire that out and automate the process of building a graph of that data, a time series graph. And the neat thing is, once you have them built, and you can build hundreds and hundreds of these graphs for hundreds and hundreds of locations in about 5 minutes with these scripting tools, and then you can drop them into an EIN or a GIS environment and call them up. So I just clicked on one particular well, and it called up the time series graph for arsenic for this well and compared it to the MODCA standard for arsenic. And if I want to, I can resize that, scoot it over here, and open up another one. And I can keep doing that. All of the data that I ran using this scripting program that automated the chart-making process is now accessible to me in this EIM environment. Remember, I can always take a clipping tool, I can clip this out, drop it into a PowerPoint, and share it with a client or a coworker or a manager if I'm trying to make some difference on a particular site. So these are pretty cool new things that this is all I want you to understand, that all of this is built, all of this, the whole thing is founded on the information that's in the EIM system. It's now coming out in an organized, downloaded Excel spreadsheet, and then I can take it and I can run with it and go play with it. Let me give you another example. Let's move up in scale. That was a site-specific example, but the neat thing about the EIM system now that we're all sharing the database where we compile our data about groundwater in one place across the agency, regardless of what program you're in, that is starting to allow us to look beyond the site scale and connect multiple sites or multiple well locations that have been measured or monitored or sampled by different organizations within the agency. So here what I've done is I've gone out to the EIM system and I said, give me all of the nitrate information you can find in the EIM system for groundwater. I can't even remember whether I designated a depth filter for the search. And download that. I downloaded that file, and it didn't matter who made the measurement. I might have limited it by date. I only want the last 5 years or something, but I didn't say, and it can only come from the water quality program. It can come from multiple people that measured it. But I'm synthesizing that information here in a map environment. So all I've done is I've just plotted the nitrate data that's available in the EIM system within the Sumas-Blaine Aquifer system up in the Whatcom County area. And then I've color symbolized that as a function of its concentration. If it's not a problem, green, but if it's over 10 milligrams per liter, please show that as red. And the neat thing is, in a GIS environment, of course, then you can start to compare that information to other pieces of information. Remember that Ecology's GIS services have a whole bunch of different geospatial layers of information. There's dozens and dozens and dozens out there, and they're all available to everyone to use. So, for instance, there's a facility site layer. So I can compare these nitrate concentrations to CAFOs in the facility site system and industrial discharge to ground permits. So I can start to see, let's see if there are any relationships between facilities and the nitrate data or the nitrate concentrations in the groundwater system. I can do the same thing. There's a dairy layer, and I can rank the dairy in symbol by the size of the number of cows that are there, and I can start to see, connections between, I wonder if that nitrate is related to those dairies in some way. I can also download the water level data for this area out of the EIM system, plot that data. I can use the GIS contouring tools to contour those water level heads get those contours in. I can draw in some flow arrows. Now I can start to see relationships between groundwater levels. Actually, let's leave this one on. And nitrate condition. Where is the bad groundwater heading towards? What wells are going to be impacted? I can do other stuff as well. Let's turn off the groundwater contours and turn on, here, this is I don't know how well you can see this, but this is a Surficial hydrogeology layer that's out there that's available for the Puget Sound Basin. This is a layer that came out of the either the USGS or the Washington State DNR, I can't remember which. I can start to see that. And I can keep doing this. I can look at isopack thickness in the Sumas Plain Aquifer. John Tooley and Dennis Erickson some years ago actually mapped these, the isopack thickness of the surficial sediments in the Sumas Plain Aquifer system. So I can start to compare aquifer thickness to the nitrate, or depth to water. And this depth to water, again, if we can first load in the information and normalize that information about water levels and Z dimensions for wells in the EIM system, then I can come out here to a post-processing software program and I can start visualizing that kind of thing in a map environment or a spatial environment. Really, really powerful tools. Again, I can clip these maps, put them out to PowerPoint, print them out, share them with coworkers, or your managers, your clients, your regulated party, whoever. So we've gone to a site scale, regional scale, and now we're going to look at a state scale.
So this is, yeah, as Charles said, this is just a state version using water levels of the sort of mapping capabilities, hydrograph visualization tools that he was showing at the local scale. So in this case, we exported all of the water levels in EIM that had been normalized as elevations, downloaded the locations, and then these dots represent the locations that have elevations for water levels. So we can use the same pop-up dialog that he was showing. Let's first zoom in maybe to the area here. So in total, there's about 5,000 locations represented here. The graphs took about 10 minutes to generate using this R script. So you can generate a huge amount of data very quickly with some of these tools. So as a water resources person, this is a hugely powerful visualization tool. Imagine that you were doing a water right inspection for an area. Somebody wants to put in a new irrigation well, and they want, 3,000 GPM worth of water out of an aquifer. With a tool like this, you could go in and say, what's happening to the water levels in that area? Maybe we don't want to be issuing 3,000 GPM more here. We seem to have a downward trend just visually on a number of these wells. You can imagine the power of this. The other thing that we can do, remember we had those aquifer tests linked to the well logs for a number of these wells. We can say, where might there be aquifer tests in this area? Well, there don't happen to be any here, but imagine that we were working in some other place in the state where we've actually cataloged the aquifer tests. Imagine we were working up in the Squim Dungeness area that Charles showed earlier, or perhaps down here in Clark County. We were asked that same question, should we be permitting more wells? Well, we now have the ability to look at the hydraulic properties for this system in a way that we never have before. Each of these dots represents an aquifer test, which we can get to by looking at the well summary page. We can also link directly to the well log. So one of the features that ArcView offers is not only a pop-up function, but it also offers a hyperlink function. So if you have a field, and let me show you how that works. If you have a field that has an active hyperlink, so this is essentially that well summary information as it's been pulled into ArcView. You can see down here that we have an HTTPS hyperlink to the well log image. So we can use that hyperlink either manually within the table, or we can use that tool that I was just showing you to access the data. Ask me later. So essentially, here's the data for the well log, and here's that aquifer test. So very quickly, we can get to this information outside of EIM now, within a map environment. Hugely powerful. You know, the hyperlink essentially provides the same functionality. The blue dots represent wells that have a hyperlinked well log. So that's essentially what I wanted to show, just to sort of get you thinking about how you might use this information outside of EIM now that it's all been tabulated and normalized and made available to you. We could do this sort of analysis with nitrates. It doesn't have to be water levels. Arsenic, chloride, whatever the variable is that you're interested in. These scripts can be modified very quickly, and you can generate graphs, you know, tremendous amount of graphs in a very short amount of time.
I just want to, we have a couple of minutes left here. I just wanted to, with the post-processing examples that we've shown you about how to download EIM data and take a look at it visually or evaluate it. Our examples so far have been two-dimensional, but don't forget that we have all this effort poured into making the data normalized in 3 dimensions. And there's a lot of cool software programs out there that allow you to do this. I've just dropped EIM data that I had for a project up in the Bellingham area. I was doing some direct push drilling and collecting some samples. In this case, it was, I think, PAHs. There was a particular surface under the ground that I was tagging to, and I wanted to know what kind of concentrations were happening in between the land surface and this aquitard surface. And so I pulled the EIM data, which is again normalized in X, Y, and Z coordinates, into the RockWare software program, and it allows me to visualize things in 3 dimensions. That's pretty cool. And remember that as we move more and more into groundwater numerical models, we can do the same thing in, you know, groundwater vistas or VMod Flex. If you have water level data that you're using to calibrate your model to, all that stuff could come out of EIM in an organized coordinate fashion and be put directly into modeling software, and you're off and running. So the sky's the limit, and the EIM system is the foundation on which it's all getting organized and standardized.